Proxima Centauri B is a planet orbiting the habitable zone of the red dwarf star Proxima Centauri in the constellation Citrus. Can also be referred to Proxima B as Alpha Centauri CB. The host star is the closest star to the Sun at a distance of about 4.2 light years from Earth and is a part of the larger triple star system Alpha Centauri. Proxima B and Proxima D, along with the currently disputed Proxima C, are the closest known planets to the solar system. Proxima Centauri B orbits its parent star at a distance of about 0.04848 AUs, 4.5 million miles, with an overall period of approximately 11.2 Earth days. Its other properties are only probably understood as of 2025, but it is probably a terrestrial planet with a minimum mass of 1.06 Earth masses and a slightly larger radius than our Earth. The planet orbits in the habitable zone of its parent star, but it is not known whether it has an atmosphere, which would impact the habitability probabilities. Proxima Centauri is a flash star with intense emissions of electromagnetic radiation that could strip an atmosphere off the planet. Announced on 24th of August 2016 by the European Southern Observatory, Proxima B was confirmed via 2 years of Doppler spectroscopy measurements of its parent star. The detection of Proxima Centauri B was a major discovery in planetology and has drawn interest to the Alpha Centauri star system as a whole. As of 2023, Proxima Centauri B is believed to be the best known exoplanet to the general public. The exoplanet is proximity to Earth offers the opportunity for robotic space exploration, which would take thousands of years, let's be honest. I mean, discovery. Proxima Centauri has become a target for exoplanet searches already before the discovery of Proxima Centauri B, but additional studies in 2008 and 2009 ruled out the existence of larger than Earth exoplanets in the habitable zone. Planets are very common around dwarf stars, with on average 1 to 2 planets per star, and about 20 to 40% of all red dwarfs have one in the habitable zone. Additionally, red dwarfs are by far the most common type of stars. Based on observations with instruments at the European Southern Observatory in Chile prior to 2016, motion anomalies were identified in Proxima Centauri that could not be satisfactorily explained by flares or photosynthetic activity of the star. This suggests that Proxima Centauri may be orbited by an exoplanet. In January 2016, a team of astronomers launched the Pale Red Dot project to confirm the spherical exoplanet existence. On the 24th of August 2016, the team led by Aguilera proposed that a terrestrial exoplanet in the habitable zone of Proxima Centauri could explain these anomalies and announced Proxima Centauri B's discovery. In 2022, the exoplanet Proxima Centauri D, which orbits even close to the star, was confirmed. An exoplanet candidate named Proxima Centauri C was reported in 2020, but its existence has since been disputed due to potential artifacts in the data. The claim is existence of a dust belt around Proxima Centauri remains unconfirmed. And this is the HERP stratigraph right here of the first 3 months of 2016. Um, Physical properties. Proxima Centauri B is the closest exoplanet to Earth at a distance of about 4.2 light years. It orbits Proxima Centauri every 11.185 days, a distance of about 0.048 AUs, over 20 times closer to Proxima Centauri than Earth is to the Sun. As of 2021, it is unclear whether it has a significant elasticity, but Proxima Centauri B is unlikely to have any activity. The age of the planet is unknown. Proxima Centauri itself may have been captured by Alpha Centauri and through not necessarily of the same age as the later pair of stars, which are about 5 billion years old. Proxima Centauri b is unlikely to have stable orbits for moons. Overview and comparison of the orbital distance of the heavenly zone of Proxima Centauri compared to the solar system. Interesting. Yeah, there's the habitable zone of Proxima Centauri, much closer than Mercury. I mean, it's a very small star in comparison to our sun. Um, and mass range and composition. As of 2025, the estimated minimum mass of Proxima Centauri b is 1.055 Earth mass. Other estimates are similar. And all estimates are a minimum because the inclination of the planet orbit is not yet known. Wow, interesting. Assuming an inclination of 47 degrees, co-polar with its host star rotation, its true mass would be 1.44 Earth masses. This makes it Centaurus, but the radius of the planet is poorly known and hard to determine. Estimates based on possible composition gives a range of 0.94 to 1.4 Earth radii. Its mass may border on the cutoff between Earth type and Neptune type. If that value is lower than previously estimated, depending on the composition, Proxima Centauri b could range from being a Mercury-like planet with a large core, which would require particular conditions early in the planet's history, to a very water-rich planet. Observations of FeSi and magnesium radios of Centauri may allow a determination of the constitution of the planet. Thus, they are expected to roughly match the radios of any planetary bodies. In this Proxima Centauri system, various observations have found solar stellar radios of these elements. Little is known about Proxima Centauri b as of 2021, mainly because its distance from the star in its orbital period, but a number of simulations of its physical properties have been done. A number of simulations and models have been created that assume Earth-like composition and include predictions of the galactic environment, internal heat generation from radioactive decay, and magnetic induction heating, planetary rotation, the effects of stellar rotation, the amount of volatile species the planet consists of, and the changes of these pyramids over time. Proxima Centauri b likely developed under different conditions from Earth with less water, stronger impacts, and overall faster development, assuming that it formed at its current distance from the star. Proxima Centauri b probably did not form of its current distance to Proxima Centauri, as the amount of material in the protoplanetary disk would be insufficient. Instead, the planet or protoplanetary filaments likely formed at a larger distance and then migrated to the current orbit of Proxima Centauri b, depending on the nature of the persistent material, and may be rich in volatiles. A number of different formation styles are possible, many of which depend on the existence of other planets around Proxima Centauri, and which will result in different compositions. Tidal locking. Proxima Centauri b is likely to be tidally locked to the host star, which means it has one side facing at all times. I mean, it's an eyeball planet, which for a one-to-one orbit would mean that the same side of the planet would always face Proxima Centauri. It is unclear whether conditions can arise under such circumstances. A one-to-one tidal lock would tend to be an extreme climate with only part of the planet habitable. Mostly the Terminator, I mean. However, the planet may not be tidally locked if the density of Proxima Centauri b was higher than 0.1 0.06. It would trend during Mercury like 3 to 2 recondits or higher order recondits, such as 2 to 1. Additional planets around Proxima Centauri and interactions with Alpha Centauri could excite higher velocities if the planet is not circular captured into a non-tidally locked orbit would be possible even with low velocities. A non-locked orbit, however, would result in tidal heating of the planet's metal, increase of volcanic activity, and potentially shutting down and a field generating domino. That's interesting. I thought the spin created how create the domino. the, the exact dynamics are strongly dependent on the internal structure of the planet and its evolution in response to tidal heating. Its host star radiates only 0.005% of the amount of visible light that the sun does, and averages about 0.17% of the sun's energy. Despite this low radiation due to its close orbit, Proxima Centauri B still sees about 70% of the amount of energy that the Earth receives from the sun. That said, Proxima Centauri is also a flare star, with its electricity at times varying by a factor of 100 over electron hours. Yeah, pretty amazing. Proxima Centauri has 12.2% of the sun's mass and 15.4% of the weight of the sun with an effective temperature of 3,500 Kelvin. And it's an M-class star. Interesting. The climate. I mean, this is a lot. This is quite the article. I'm gonna get back and make another video on this.